I'll record. Okay, I'm recording now. This is a lecture in behavioral economics, the last lecture before the midterm exam, and we're going to finish talking about prospect theory and then do some overall review. And James has left the chat. Okay, I don't think that's quite true, but let's answer Peter's question, which was how do economists think of this mathematical formula for the probability weighting function? And I will tell you this right now, that some of you are going to stop paying attention to me because I'm not going to ask you to be able to produce this. Right? So on the exam, I'm not going to say, here's a probability. Will you calculate the probability weight according to the probability weighting function? I'm sure I could have asked you to do that. I could have taught you more about the mathematics of this particular function, but I didn't, and I'm not expecting you to be able to do it. I am expecting you to know two things about the probability weighting function. And the first is the certainty effect. Things that are certain to happen are overweighted relative to things that are slightly uncertain, or something that's impossible to happen. Something that's just slightly possible is very overweighted relative to something that's certainly impossible. And that's this jump at 0 and a jump at 1. That's one effect. Sometimes it's called the certainty effect. And what's the other thing? The other thing is the insensitivity to probability changes. And you might say, what does that mean? Look at my slides. I've been talking about this for 3 times. How do you not know what that means? Okay, it means I don't react to changes in probability as much as I should. The difference between 20% and 25% doesn't feel as different to me as it actually is. The same thing with like 50% and 60%, or 60 to 70, 70 to 80. All of those are real changes in probability, but psychologically they don't our brain doesn't register those differences quite as much as it should. Anyways, those are the two things I do want you to know about the probability weighting function. Now, the actual mathematical formula, I'm not going to expect you to know. But because Peter asked, you all have Peter to blame for the next few minutes of just wasted class time because he just wanted to know what I'm just kidding. I'm glad you asked. Let's share this one. Do I have it up? I might not have it up right now. Prospect theory, here we go. I do have it up. I'm going to share this. Nope, is that the wrong one? Sorry, guys. And now I'm embarrassed that I have this. I guess I need to open it first. I thought I clicked on it. Maybe I did. Now I will share it. This is, by the way, this is the original paper on prospect theory. Oh gosh, maybe I don't want this. No, I will leave this open and we will talk about this, but let me go to the other thing in the course documents, which is the other reading about prospect theory, which is prospect theory in the wild. I wanted to talk about this paper today anyway, so it's a good segue. Prospect theory in the wild is a paper written by Colin Kammerer, my favorite behavioral economist, who found 10 instances of phenomena that occur in the wild that people actually do when they make decisions that can be explained pretty well by prospect theory, that couldn't be explained so well with other things. So he just chooses these 10 things to write about and wrote about in a paper. That's fine. What he also did, though, was talk a little bit about, I could be wrong. I could be wrong. Maybe he doesn't give a example of the probability weighting function. Yeah, he, in some sense, no, I'm not going to be able to answer Peter's question from this. I apologize. Okay, I would need a separate paper to answer that question, not this one. I think if you know a logit function, I think is it's not quite logit. I think I can answer this. Um, what's the name of these functions, or what does it look like? Um, I had it once. Can't find it. Let me look at the chat. You're welcome. I'm dropping this class. Oh, great. Admit. Yes. So did you search for the answer to this question on your own? I believe, let's see, the weight of probability P is equal to, it's something like, so it's a fraction where the numerator is P raised to some power, and the denominator is like 1 minus P raised to some power. Does that work?
So just an actual logit function of x over 1 minus x?
So,
Have to have some kind of push up so that it's above the x-axis.
oh, are you asking, is there some discontinuity at zero? There does not have to be a discontinuity at zero, by the way.
No, but I think, never mind. It doesn't really matter. I was just curious if there was some generalized formula that behavioral economists use for all sorts of situations.
It's a fair question, and all I can tell you is there are some commonly used formula for probability weighting function. I haven't committed it to memory, unfortunately.
Okay.
And that's because this really isn't something I would use in my personal research. If I let's say did an experiment and we're just trying to analyze some sort of abnormal behavior, I could use this tool. I could say, we can explain this behavior by using a probability weighting function. Here's a formula for the probability weighting function, and it actually explains the data better than not having it. I just happen to not have done a research that requires that tool. And I think that's why I haven't committed it to memory. But I think, can I just explore this question a little bit longer? Have some patience. I know everybody wants to review for the midterm exam. So if I take too long, we'll just give up and say, no, sorry, I won't remember it. But let's get a probability P and a weight WP. You can't see what I'm doing right now. I'll share it with you so you can actually see what I'm doing. I'm just going to open Excel and look a little bit at some of these numbers based on what I remember it to be. So like, let's say you have a probability of 0, 0 0.1, 0 0.2. It sort of goes like this, all the way to 1. I think I'm sharing my Excel screen now.
Yeah, we can see.
Okay, and so those are the probabilities from 0 to 1 in an increment of 0.1. What would the probability weights of this look like? What kind of a function? I actually think it's something like this. Something like the probability, actually, okay, so when I press to the left, it means the probability immediately to the left. Raised to some power, I actually think it's less than 1, like 1/3 or 1/4. I'll say 0.25. The probability raised to a small power like 0.25 divided by 1 minus this same probability raised to also a small power like 0.25. If I recall, it's something like this. Now let's see what W of P would be if we did that. I'm going to hit down and it'll just fill it all in. Oops, that was wrong. Okay, what did I do wrong? That's embarrassing. Yeah, the denominator should always be bigger than the numerator, and that apparently isn't happening here. Did I do this formula wrong? Let me try a different exponent. Here we go. That's not quite working too. Shoot. Um, yeah, so it should, I know what it looks like, but I'm not getting the formula for it right. Geez, I'm sorry. I will have to get back to you on this, Peter. I can draw it for you. I just can't remember what the formula is. Let me draw it for you. The one that doesn't have, sorry, let me do the whiteboard. Okay, so if this is this is W, the weighted probability. This is P, the actual probability. I don't know why it's red. I would rather have it be in black. You can make sort of a symmetric looking thing that looks like this. And it doesn't have any gaps. It doesn't have the discontinuity that Kahneman and Tversky had originally in their paper, but it has this steepness here that captures that. That if you have a probability that's just slightly greater than 0, it's going to jump way up in the weighted probability. And there is a way to construct this graph using a formula, and it's similar to what I wrote, but I just couldn't recall it exactly right. I apologize. So I mean, that's my answer. It shouldn't take you that hard to search for it. I'll search for it after class and let you know. But that's not important for this class. What's important for this class is that you kind of get this idea that so for most of this time, this is a flat, at least for the interior probabilities, ones that aren't close to 0. So forgetting about these probabilities or these probabilities, except for those endpoints, everything here in the middle, this sort of middle section here, the function is flatter than a 45-degree line. And because it's flatter than a 45-degree line, it means we're insensitivity to change. We're relatively insensitive to changes in probabilities in that interior section. And on the ends, where the probability is close to, I'll do in green here. These are sort of like the end regions. These regions here. That's when we're very sensitive to changes in probabilities, because we feel like there's a really big difference between 0% and 0.001%. Even though it's really unlikely, somehow just the possibility of it makes that element of that decision is overweighted in our mind. And that's the point of the probability weighting function. Sorry, this is so sloppy. Okay, let's go back to, did I answer everyone's questions about the chats? Let's go back to sort of wrapping up prospect theory. I'm glad we had that little discussion about the probability weighting function, because it's a great review for what we've already talked about. The other big part of prospect theory you should know is called the value function. Maybe I should draw for you the value function and talk about it while I'm drawing it. Oh, I have this monstrosity still here. Clear my drawings. Okay, now I want to draw a value function. For that, I should have two axes that cross with the point in the middle. What's this point in the middle called?
Reference point.
Yeah, the reference point. The reference point is a very important aspect of profit. I'm not even going to try to, you know what it is. That is the reference point right there. It's sort of a very important aspect of prospect theory, because it doesn't exist in expected utility theory. Expected utility theory says people make decisions over uncertainty based on the utility they gain on their final outcomes. It doesn't matter how you get to the final outcome. It only matters where you end up. Whereas prospect theory challenges that notion by saying it actually does matter where you started, because if where you ends up is in the domain of gains. You feel a certain way about those gains. If it happens to be in the domain of losses, you feel a very different way. Okay, so the reference point is kind of where it all starts from in prospect theory. Now from here, we have this value function. By the way, the axes are V for value. This is sometimes called X or Z, but you just think of this as these are losses and these are gains. And they're measured somehow. You might think of it just that you might think of it measured in dollars. Yeah, even though not everything is always measured in dollars, you could, but you need some way to plot it on an axis. And V tells you how happy you are with this outcome. Positive V, the up V is better, lower V is worse. And it has this curved feature in the value function that says there's diminishing returns to gains. The further I get in the domain of gains, the sort of flatter I go in my value function. That means I still am happier. You give me $100, I'm happy. You give me $110, I'm happier. 120, I'm happier. 130, I'm happier. But for each additional $10, the additional joy I feel is diminishing. That's the point. That's pretty uncontroversial there. Here's the weird thing. In the domain of losses, we get a real steep slope, and then it starts to go down this way. So I don't know if I drew it. Is it obvious from how I drew it that there's loss aversion? Because loss aversion is part of prospect theory. It's built in because the slope is so steep here. By the way, that was an answer on the quiz we had at last time. A lot of people may have said something like loss aversion is because of the convexity of the value function. That's just not true. You could have a here, let me draw in red. Here's a function which is convex, but there's no loss aversion there. Think about it. If this red line were the true value function, you would actually think gains were more significant than losses. This would be the opposite of loss aversion. This would be loss tolerance. Like, I don't mind losses that much. I'm tolerant of my losses, if the red line were true. But notice the red line is still convex. Why did I draw this? To make a point, that is, it's not the convexity of the value function in the domain of losses that gives rise to loss aversion. It's the slope. The slope of this function is so steep here. I tried to draw it very steep, the domain of losses. That's why psychologically, this additional pain we feel when we experience a loss comes into view in terms of this value function. That's the answer to that. So let me summarize the things you need to know about, remember this eraser, will that just erase? I thought that would erase the red. Yeah, it did. The things you need to know about the value function: has the reference point. It has risk aversion here, doesn't it? Text, maybe I'll do some text. Risk averse. In other words, concave, because the value function is concave over gains. See that? How about losses? Risk. What's the opposite of risk averse? There's two names for it, either risk loving or risk seeking. I don't know, risk seeking sounds a little more professional. Like, are we really talking about loving? No, we're just talking about you seek out risks. You want to have risk-taking behavior over losses. Okay. Can I shorten this so that's not, I don't know. There you go. Okay, and one other thing. They got the reference point. We got the concavity over here, convexity over here, and there's something else right here in the middle and that's loss aversion. More text. Want some more text? Loss aversion because of the slope. It's because of the steep slope near the reference point in the domain of losses. That's where it comes from. So I don't know if you can tell from this whiteboard that I put up. It's that I'm giving you the economic effect, which is risk aversion, and then I'm also telling you what is it about the value function that gives rise to the risk aversion? Well, it's concave over gains. Same thing with losses. Risk seeking is the behavior. Convexity refers to the shape of the function. And same thing here. Loss aversion is a behavioral phenomenon. What is it about the value function that gives it? The steep slope near the reference point in the domain of losses. Does that make sense? I think I've really summarized all of prospect theory for you. There's some more framing effects that we could talk about, and there's a video about that too if you'd like to watch. In particular, by changing the reference point, you can change people's behavior, and I think that's an important feature too. If I tell you there's 600 people afflicted by some disease, and you can save 200 people from this disease, you think of it in a certain way. Whereas if I tell you 600 people will be afflicted with some disease, and you can make it so that 400 of those people will die, the outcome is the same. 200 people survive, 400 people do not survive, but whether or not it's framed as a gain or a loss actually influences which policies we prefer. And that's weird, isn't it? Like, let's say you're actually in charge of a country, like, or you're in the CDC. Like, we do have a pandemic going on right now. I would hope that the people who are making decisions about the pandemic that actually affects us all are doing it in sort of this cold, calculated way. What's the best thing we can do for the country? But the behavioral economics, and of course, this comes from psychology. The psychology behind it says we are really, really affected by these sort of subtle ways in which the information is presented to us, and the ways that we present information to other people can affect how they feel about whether they think you're doing a good job or a bad job. It depends on how you present this information relative to what, and in terms of what, the people that you save, the people who die. That's a consequence of prospect theory that I do want you to know about. It's not on this graph, but just know there's a frame. Sometimes those are called framing effects. I don't know where to draw the framing effect on this graph, because literally I can't draw it on this graph because it involves reframing the reference point and doing something else. For example, I can't draw it, but I will talk about it. There's this quote in Predictably Irrational, this book, that talks about it. He's not actually talking about prospect theory, but it involves prospect theory, that somebody who drives a certain type of car, eventually they get happy with their car, but they want a better one even. Like, let's say you're a very rich person and you hang out with other rich people, and there's like a Porsche or I forget, I have the quote in my slides, but the point is, this guy who's a very rich guy, he decides he just wants to drive a Prius. He's not even going to bother thinking about what's the coolest car, the best car that you drive, because if you buy a Porsche Boxster, then you actually start wishing you had a Porsche, was it 911, 911? How do you say that? And then once you buy a Porsche 911, you wish you had a Ferrari, and it's sort of never ending. What does this have to do with prospect theory? It's that eventually your reference point does change. Something that you thought of previously as a big gain, like this brand new fancy car that you're driving, eventually that becomes neutral. That becomes your status quo. So whereas before, the difference between a Porsche Boxster and a Porsche 911 doesn't seem like a big difference. Once your reference point changes so that you are the owner of the Porsche Boxster, it does seem like a big difference, because if you notice the slope of the gain, even in just looking at the domain of gains, the slope is steep close to the reference point, and it's not so steep when you're farther from the reference point. So that's also an implication of prospect theory. Peter, you have a comment? Oh, that's you had a comment.
No, I just found the formula is all.
Oh, you did?
Yeah.
Was I close?
Yeah, it's just a little more complicated.
Okay, darn. I, it's like in there in my memory. I just couldn't extract it in real time. I think it's because James asked me to record this. I was being self-conscious, like, oh no, people are going to watch me, and I actually screwed up the formula.
Yeah, James is the worst. We know.
Sorry.
Guess
No,
I just
actually,
got-
he was right to tell me to record this. I should have been recording. Let's go on to prospect theory in the wild. Oh, before that, I want to talk about the phase of prospect theory that I haven't mentioned much, and that's called editing. There's value function, probability weighting function. This third phase is called editing, and what that means is, oh wow, p raised to the beta divided by p raised to the beta plus, that's what yeah. Thanks. Now that I see it, I remember that. I didn't have I had 1 minus instead of p to the beta plus 1 minus p raised to the beta, all to the 1 over beta. That sounds right. Okay. It's hard to remember. Why do I need to memorize that? I've got better things to memorize, like all of the lyrics to Hamilton. Okay. Let me just talk briefly about the editing phase of prospect theory. It can be summarized like this. What's really going on here? If I give you a bunch of options and say, okay, choose from these options, this is what can happen to you. The theory says you don't just evaluate everything based on exactly what it is on its face. Literally, you're not foolish and just taking everything so literal. What do you actually do? You edit what is being offered to you, to process it in a way that the theory makes sense. Let me give you an example. If I gave you an option that said, either you can pay $10 right now, you give me $10, or you give me $100 and I'll give you $100 right back. I'll hand it right back to you. Those are the two options. What would you rather do? Pay me $10 and I keep it, or pay me $100, which I give right back to you. Think about these two options. Which one's better? Obviously, the one where I hand it right back to you, right? You give me 100, but I hand it right back to you. You don't lose anything. And let's assume liquidity. You know this term, liquidity. Liquidity is not an issue. It's not that you can't even find $100 to borrow or just to have. You can find the $100. You hand it to me, I have it, and then I hold it, and then I give it right back to you. And there's no doubt that I'm going to do it. I'm not somebody who might just run away with your money. Of course, any rational person would say, I want to do the thing that doesn't cost me anything instead of the thing that costs me $10. But what does prospect theory say about these losses? If they're not combined, if you treat a $100 loss or a $100 gain really differently, then of course that $100 loss is going to be really steep, really bad for you. Then you'll get $100, and that's not as good because of loss aversion. You could say the theory predicts that you will avoid that outcome and choose the one where you just pay $10 for sure. But that doesn't make sense. So the solution is, because of editing, when you have an option that's pay 100 but get 100 right back, those are combined. Those two scenarios are combined into one. I mean, and of course I gave you this thing with certainty, but it really, it's ridiculous in the case I just gave you, but it might not be so ridiculous in the cases of probabilities. When you're thinking of something probabilistically happening, you're not so foolish that you can be taken advantage of, because you're thinking of all of these different gambles, these probabilistic gambles, separately. For example, if I toss a coin and if it's heads and tails, you get the same thing, then the coin toss didn't matter. there's no probability weighting function that should affect your decision making for an event like tossing a coin, where the outcome of the coin toss doesn't matter. If it's heads, you win $10. If it's tails, you win $10. If you took the probability weighting function and distorted the probability in some way, you may actually choose a different outcome that's worse than that. But that's ridiculous. So the editing phase, I think I will just show it to you briefly. Maybe you were supposed to read it, but I don't think I actually had you read. Where is it? I don't think I actually had you read the. This one? No. Sorry. It is here. Get out of the way. There we go. I got it for you. I just need to share the right thing. Right here. Okay, this is the editing phase of prospect theory as initially described by Kahneman and Tversky. Coding is the first thing that happens. This is like evaluating everything relative to the reference point. And of course, that's part of the theory. Combination, you combine outcomes that are the same. So I'm with my cursor, I'm highlighting these two options where you get $200 with 1/4 of the time. You also get $200 another 1/4 of the time. You should combine those two outcomes into just getting $200 half of the time. In other words, you don't want to evaluate the probability weighting function at 0.25 and then evaluate it again at 0.25 because those are the same outcome. You should use the probability weighting function, but only do it at 0.5. Okay, and that's called the process of combination. By the way, I'm not gonna ask you to know about each of these different phases, the editing phases. Like there's coding, combination, segregation, cancellation. There might have been some more. Anyways, I'm not gonna ask you to give a list of all of these things. What I do want you to know is that prospect theory is applied using a value function, using a probability weighting function, but only after the editing phase gets rid of all of these sort of crazy nuisances that would otherwise lead you to do unreasonable things. Let me do one more. Let me talk about one more, like segregation. In other words, if you have something like $300 with probability 0.8 and $200 with probability 0.2, there's some uncertainty there, isn't there? You might get 300, you might get 200. But actually, you could think of this as, well, I'm getting 200 for certain. And saying, well, I get a sure gain of 200 plus the possibility of getting an extra 100 with a 0.8% chance. And you will evaluate that differently according to prospect theory than you would if you thought of, if you took 300 and 0.8 and did your probability weighting function, and then you did 200 with 0.2 and then did your probability. You see what I'm saying? There's an element of that prospect that's certain, and the certainty effect should kick in there. Even though you don't know for sure if you're getting 200 or 300, you do know for sure that you're getting at least 200. And because of that, there is some peace of mind that you should feel from the fact that you're getting at least 200. Okay, I think that's all I want to give you, these sort of examples of at the editing phase of prospect theory. And finally, let's talk about prospect theory in the wild. We don't have time to go through all 10, of course. So let's pick some of my favorite ones. Oh, if I just do this, I can switch to prospect theory in the wild, and I think you can see me. Finance, the equity premium. That's a pretty cool one. I think I might even talk about that in the video. So I have a video of prospect theory in the wild. And once again, in the video, I just kind of choose the ones that I think are the most interesting to talk about. Well, let me talk right now about the equity premium. First of all, this isn't equity in the terms of like what's fair and giving people equal opportunity. In this phrase, the equity premium refers to it refers to an asset whose value is uncertain. That's what it means by an equity. And you could think of these as, let's think of them as being stocks or bonds. People, investors have the option to buy either stocks or bonds with their investments. And what's the difference? Bonds are safe. You know how much you're going to get approximately. You actually don't know when you factor in inflation, you don't know how valuable a bond is going to be. In other words, if you get a bond that has a 1% return, but inflation is 3%, then you're sort of losing money in real terms on the bond. So there's some uncertainty with the bond, but there's a lot of uncertainty with the stock. If you buy an equity that's based on stocks, there's a lot of uncertainty. So what's the equity premium? It's this. The rate of return on stocks is approximately 8% higher per year than bonds. And that's a big difference. If you invested your money in the stock market versus the bond market, you would get 8% more of a return on average, looking back for the last 100 years. Actually, I'm not sure if it's 100 years. That's called the equity premium. That's a real thing. Here's what prospect theory has to say. The reason this equity premium is so high, it's so high that it can't really be explained by expected utility theory. By the way, if you just read this paragraph that I have highlighted here, it says a person who is so risk averse that they would have this normal equity premium, they would rather have $51,000 than a coin flip, which pays 50,000 for heads and 100,000 for tails. You'd have to be pretty crazy, right? Someone says, would you rather have a coin flip that pays half the time pays you 100,000 and the rest of the time 50,000, or a fixed payment of 51,329? According to expected utility theory, if that's where the equity premium is coming from, you would have to be indifferent between the 100K gamble and the 51,000 for sure. And that's just crazy. People would, you would have to go for the 100,000. It's so much more attractive. Okay. Bernardsey and Thaler, though. Thaler is a very famous behavioral economist, showed that if you use Kahneman and Tversky's prospect theory functions that they estimate not in their original paper, but the ones that they talk about in some of their later work, you can explain this equity premium pretty accurately with a loss aversion slope of 2.25. That means, losses are weighted about a little over twice as much as a bad thing as gains are regarded as a good thing, which is pretty accurate. That's people's loss aversion is usually, I usually say between 2 and 3 times as bad a loss is than a gain. And also, if you imagine their horizon in the future as 1 year, I think that's pretty reasonable, isn't it? Let's say you're an investor. Every year you have to pay taxes on it. So, 12 months is a pretty good window where you evaluate how well did I do the last year in terms of investment. So if you use prospect theory, you can explain, in fact, you would predict, it matches the data, this 8% equity premium. The one that's really hard to explain with expected utility theory, because you'd have to refuse these really good gambles. But in prospect theory, because we're afraid of losses, or at least we really dislike losses, that explains why people would invest in the bond more so than the stocks, even though there's an 8% difference in the expected returns. Okay? That's one example of prospect theory in the wild. And there's 10. There's 9 others. I can't give you every 9. All the others. If I were to give you one more, it would be it would be labor supply. Yeah, yeah, yeah. And that is, I made a great video about it. Watch my video on prospect theory of the wild. In that theory, in that video, I talk about New York City cab drivers who decide to stop driving their cabs on the days where it's raining, and actually they could make a lot of money because people really want to hire cabs when it's raining. This is before the days of Uber, right? This research was done in the 90s, actually early 2000s. I think late 90s, about labor supply that says, using prospect theory, we can explain why these cab drivers don't take advantage of this fact that they could earn a lot of money on the days where where demand is really high. You know, Uber fixed this, didn't they? They actually give you more money. They charge a higher rate for people when it's on high demand. And so the cab drivers, they have an incentive to keep driving. The Uber drivers have an incentive to keep driving and even to drive more when it's high demand because they get paid more. But the cab drivers in New York before Uber did not. And here's how you can explain it using prospect theory. The prospect theory says, if you have a reference point that includes, it's not just how much money do you currently have, but it's how much money do you expect? What do I think I should earn every day driving a cab? If you're below that expectation, if you thought you were going to make $200 today driving a cab and you only made 150, you feel pretty bad about that. That's almost, it's experience in the domain of losses. And you will keep driving until you reach your reference point of 200. Whereas if you've already made $200 today, you have an opportunity to make some more. You're just generally not as interested in doing that because that's the domain of gains. You've already made up all of your quote unquote losses. Sometimes it's literally a loss. Just let me explain quickly why that is. If you have to rent your cab, let's say you're paying money to rent your cab, and you got to make up the losses for that. Otherwise, it truly is a loss. Anyways, because of that, because of this loss aversion and the reference point and the framing effects that were happening, this really happened. This really happened that New York City cab drivers were less, they were less likely to drive on the days where the demand was high and or at least to continue driving. They provided less labor supply on those days where they could have earned a higher wage, which is totally backwards from what economics predicts. Standard economics predicts that your labor supply curve should be upward sloping. All supply curves are upward sloping. All demand curves are downward sloping. Labor supply is no different. It should be upward sloping. In other words, that the more wage I offer you to attract you to work, the more willing you should say, okay, yeah, I'll do it. But we find the opposite. We find the opposite, that these cab drivers were like, I'm just going to stop working. I've had enough. And I think prospect theory does a good job of explaining that. Okay, those are my 2 examples of prospect theory in the wild. If you'd like to read more, I encourage you to look at the other 10. The other 8, sorry. Stop share. What do we want to do now? Let's talk about some review. I was debating whether or not I should give you a comprehensive, not literally, it's of course, I shouldn't have said the word comprehensive, but it is a summary of the topics we've talked about in this class. And I decided I'll give it to you. The reason is if I didn't post it on Blackboard, there's probably somebody who could have found it from like a previous year. And I didn't want someone to have an advantage over somebody else. So now everybody has it. If you go to Blackboard under course documents, I believe, under course documents, I have posted something called Summary of Pre-Midterm Topics. Maybe I'll share that screen now. Okay, So just as a way to review, why don't we look at it? Here you can see now I'm on Blackboard. If I go to summary of pre-midterm topics, here we go. It's a PDF file. I'll open it on its own tab. Let me zoom in a little bit. That's too much. Anyways, here we go, guys. Here's a list of some stuff that we've talked about this semester so far. And so the main topics are introduction to behavioral, cooperation and coordination, preference reversals, endowment effects, status quo, loss aversion, biases, heuristics, thinking relatively, fallacy of supply and demand, prospect theory. And that's it. And then I have these matching portions from last year's midterm. I'm not saying I'm going to use the same ones this year, but it's pretty reasonable that I'll keep it pretty similar, and ask you some matching. So you know what I found about matching? People who know the material think that matching is actually really easy. It's in fact, if anything, it's easier and faster than multiple choice. But for people who don't know the material, they find it to be a lot harder than multiple choice, because instead of just having 4 choices, there's 1 right answer and 3 wrong answers. When there's matching, there's a lot of possible answers. And if you're sort of guessing, then it actually hurts you. It makes you perform poorly in the matching section. But I hope you guys all are good students and already have an understanding of this material, in which case the matching section I think should be pretty easy for you. These will be the options to choose from. I might give you a little description. Let me give you an example. This effect is perhaps the best way to explain why a realtor can show someone a house that is very similar to a house they want them to buy, but worse in some predictable and obvious way. And I'm not wording this. I will make sure I word my question a lot better, but I will give you this sort of example that says a realtor can present somebody searching for a house with an option which is clearly inferior to house A, but it's hard to compare to house B. And that makes the person more likely to want to buy house A. Which of these options is the best way to explain this phenomenon? And you'd have to answer that. You probably know the answer. Some of you do. Should I just tell you? The decoy effect. That's the decoy effect, right? Because the house that's obviously worse than house A serves as a decoy, which because our consumer choices are relative, are often made relative to other options. If we have this one relative comparison that's really easy to make, the presence of that decoy makes us want to buy the house that's obviously better than it. Okay, that's an example of a question I might ask for the matching section. Will the matching be more definition-based or application-based? I think I'm going to try to make it more application-based. The issue with asking you definitions is I'm providing you with all the definitions. You can read them in this document. It seems like an odd form of a midterm exam if I just say, go look up the definitions that I gave you in this document and give them back to me. And you get an A. I could do that. I would be worried as an instructor that you don't actually retain this information at all in the future. You simply just copy down what I said back to me, then forget about it and can't use it in the future. So I'm trying to help you learn this material in a way in which you will retain it and get some benefit from it in the future. So more application based. That doesn't mean I will, that doesn't mean I might not also ask you some that are pretty much definitional. I might. There's certain ones that the really only way I can ask you is the definition. That's fine. I hope that answers your question. Michael, you'll have to talk to me later. I don't know what you mean by retake the quizzes. Okay. But I want you guys as practice. They're still open. I think you can. Is it possible? I don't know. I've never done the Blackboard as a student. Of course, for me, I see it as an instructor. I don't think it will mess up the gradebook. I know what you're asking. I think I have a setting where I had to choose if I just accept the first grade and ignore all future attempts. And I did click that button. So your first grade is the one that will stay in the gradebook, not your future attempts. Unless I failed to click that button or accidentally. But if not, it's my fault. Go ahead and retake the quizzes if you want. Can I ask you guys if you would like me to talk about any of these? And we have 15 minutes. I'm sorry I didn't give you more time, but does anybody have any questions they would want me to talk about anything from this document? Something maybe from a long time ago that you've forgotten, or something new that that you still want to hear more about? Does anybody have any questions? Or it doesn't even have to be a question. It can be, can you explain this concept again? It can be that. I hope I can hear you if you say something. I have my volume up to 32%. It's not high, but. Should I zoom out so you can see more of this document maybe? No, still. It's harder to read this way. You guys have any questions? I mean, not just questions, but concerns or just topics you'd like to talk more about. Please feel free to speak up. If you do, you know, probably somebody else is thinking the same thing. They want to hear more about, for example, preference reversals. Remember what a preference reversal is. It's not just changing your mind. Remember that. Preference reversal is not the same as, I used to think I liked this thing better, but now I changed my mind. I like the other thing better. It's a little more nuanced than that. I have difficult. Okay, is this to everyone? Yeah. Understanding preference reversal and probability gamble. Why is low probability gamble worth more than high in cash equivalents? Good question, Tony. Why is low probability gamble, quote, worth, unquote, more than high in cash equivalents? Well, I don't think I understand exactly what you're saying, so let me just try to answer what I think you mean, which is, why do people tend to give a higher cash equivalent for the low probability gamble? That is what you're asking. That's what you're asking. A good question. And the answer is, well, for one, this is how all science works. We can never know for sure, but what we do is we gather evidence. And Grether and Plott were the economists who gathered a lot of evidence about this. And then so did some other behavior economists. I think even maybe Thaler got in on this and did some experiments. And here's what I'll try to summarize what they found. First, I'll tell you what it's not. It's not that people are intransitive. It's not that people somehow think A is greater than B, A is better than B, B is better than C, yet C is somehow better than A. that would involve a bit of literal irrationality and inconsistency in the preferences. That's called intransitivity. And that could be why this preference reversal happens, but actually that's not what they just find out. They find it has to do with the way, which aspects of the gamble are consistent with the way the question is asked. So in other words, if you have a low probability gamble, that means it has a higher payoff if it wins. And the higher payoff is something which is valued, which is denominated in dollars, in cash. Therefore, if I ask you to give a cash equivalent, you tend to focus on that aspect of it, the aspect of the gamble that is the cash. Therefore, when you're trying to give how much is this gamble worth, you tend to give a higher value for the gamble with the high cash payout if you win, as opposed to the gamble with the low cash payout if you win, because you're focusing on that. Similarly, if you ask questions about how long are you willing to wait, how patient would you be willing to be to earn a higher value, a higher amount of money? And when they're giving cash equivalents, they focus on the cash payout again, even for this question about patience. And so because of that evidence, the conclusion seems to be the compatibility hypothesis is what it's called. The compatibility hypothesis says you focus on those aspects of the question that you're answering that are most compatible with the way the question was asked, or the options that were asked. Sure. Michael asks if I want you to know which economists are responsible for the different things we've learned. I get this question every year, like, do you have to memorize the economists and the dates? I'll say no. However, sometimes it helps as like a shortcut for you to know what I'm talking about. I might talk about Allais and the Allais paradox. So, okay, that's an exception because that's what it's called. The Allais paradox is named after the economist Maurice Allais, who not just discovered it, but published all of his work that demonstrates, hey guys, pay attention to this. Here's a way that expected utility is just wrong. Expected utility doesn't work. Here's my proof. Maurice Allais did this, and therefore we call it the Allais paradox. For that one, you do need to know the person's name. But for preference reversals, because they're not called plot reversals, Charlie Plot is a good guy. I've actually met him. I've talked to Charlie Plot. He came and he was a guest speaker when I was a student. When I was student in behavioral economics, I had Charlie Plot come to my class and give us a little talk and do some experiments with me. So I still remember him. But the preference reversals aren't named after him. They're not plot reversals. Therefore, you don't really need to know that. I want you to know about the phenomenon and the name of the phenomenon. Preference reversals. I'm not going to require that you have memorized in any way which economists were responsible for discovering them. Good question. Somebody just wants to know how many questions will be on the exam. I haven't decided for sure. I'll estimate. I will say 10 multiple choice, 10 matching, and 4 essays. That's my estimate. Please don't hold me to that, because if there's a little bit more of one or less than the other, that could happen. I may decide that I need more essay questions than 4. That it's just not that somehow there's something I really need to ask you about, and maybe 5. I'll say that. So you're not mad at me if there's 5. What else can I help you guys with? I mean, you can look over this document on Blackboard, the what's it called? Summary of pre-midterm topics, and look it over yourself. And if you find something like, wait, I don't even know what that is, or I'm reading about this, but I may have accidentally left something on this document that we didn't spend a lot of time talking about. If that does happen, I'm not going to put something on the exam that we haven't gone over in class. So I don't think I have anything on this document that we haven't gone over in class, but if for some reason that happened, then you shouldn't be worried that that'll be on the exam. What do you guys want to do the last 6 minutes of class? You know what the conjunction fallacy is? Let's look at these matching things. What's the conjunction fallacy? What's the name of the woman that Kahneman and Tversky used to demonstrate the conjunction fallacy? Linda. Her name was Linda. And she seemed like a feminist, right? They did this survey. They described this woman named Linda. I think it was Linda. And she was active in demonstrations, anti-nuclear, environmental, social justice. And then they asked you the question, is she more likely to be a feminist, or is she more likely to be a feminist bank teller? Oh, I'm sorry, I screwed up. Is she more likely to be a bank teller or a feminist bank teller? And a little more than half, not everybody, but a little more than half of the people, when asked this question, say she's more likely to be a feminist bank teller. What? That's impossible. It's impossible for someone to be a feminist bank teller and not also a bank teller. So it's also not possible for it to be more likely that she's a feminist bank teller, because that's the conjunction of two, not events, but conditions. Two things have to be right in conjunction. That has to be less likely than either one of the events. That's called the conjunction fallacy. I'm not going to make you know that it was Linda, but you do have to know what it is. The base rate fallacy is another fallacy, which we talked about a bit. That's when you ignore base rates. So you're only thinking about how representative someone looks or something is of a class, rather than, well, what's the background likelihood for it to happen? And this matters a lot for medicine. In other words, like COVID things. If you get a COVID test and it comes out positive, you need to know something about what's the base rate of the prevalence of COVID, because if it's really, really low prevalence of COVID, then if you get a positive test, it could very well have been a false positive. You actually almost expect it to be a false positive. Whereas if there's a high prevalence of COVID and you get a positive test, then it probably means you have it. But what is the fallacy? The base rate fallacy is when you ignore the base rates, and it's almost like stereotyping. This person seems like a feminist, I'm just going to assume she's a feminist, rather than considering what's the base rate likelihood that she's a feminist, or he. Men can be feminists too. What else can any of these other terms you want me to talk about? Have you guys been chatting and I mean not seeing? No, you're not chatting. You're not talking or chatting. Maybe you just want to be done with class. Is there any other questions you have? We're good, fam. Is there any other questions you may have about the midterm? It's going to be during class. I will be available in the sense that, like, I'll load up, I'll start the Zoom meeting. I may even just have it muted, but the reason I'll have the Zoom meeting up is so that you can ask me questions, instantly. If I see it instantly, I'll try to address it as soon as I can. And just so you know, I want you to ask questions if they're sort of to clarify what I mean. And I will help you in that regard. But I always try to be fair in the way I answer these questions, as to not give you some critical piece of information that other people don't have. And Just warning you. Some people are trying to be kind of clever, like they're doing a matching problem and they think it's the answer is the decoy effect. And then they say, for problem 4, do you mean when you talk about the decoy effect, do you mean in this case? And sort of, I can't even answer that without revealing whether or not I was talking about the decoy effect. Maybe I was talking about it, maybe I wasn't. But if your question presumes that I'm just warning you. I'm not being a jerk and just saying like, I'm not going to answer your question. I don't care about you. It's that I'm trying to be fair. And if you ask a question in a way that presumes a piece of information that I don't feel it's okay for me to reveal, then I might not answer your question very well. But if you ask it in a way that says, I don't understand, what did you mean when you did this? Or did you make a mistake? Or like, oh crap, I made a mistake. I better change that. And then I'll tell everybody about it. But anyways, I will be available during the exam. You can try to trick me, Michael, but I've been doing this a while. I don't get tricked very easily into telling you the answer. You guys have any other questions? Maybe we should stop and say anybody, you guys can leave. Class is over. If you do want to stick around, I might help you review a little bit more, but certainly there's nothing else you need to know for the exam on Wednesday. Uh-oh, I'm frozen. I'm going to